do this. Let's go back, go up to the top triangle, or the top circle up above. You had starting point here, here, and here, correct? We said that this was pi over 2, this is pi, this is 3 pi over 2, and this is what? 2 pi?
Yes.
Yes. Okay, now I'm going to blow your mind. So if you're sleeping, you should wake up right now. Thank you. All right, so we're right here. Circumference is running around the outside of the track, correct?
Yeah.
All right, so let's say that you were not running on the track, but you were a spectator standing at the origin. You were looking at a runner in that direction. From here, you follow the runner as they run around the track. Do you know what this on the inside is called as a measure or a unit? You do. It's an angle. What's the measurement? Degrees. So a second way that we are going to look at the unit circle is the measure of turn, or the degree. So here's my example. If I start here and my person ends up here, how many degrees did the person in the center turn? 90. So on the inside of here, please note that this is 90 degrees. Remember, we're always starting at X and we're running in this direction. Now this is where that warm-up comes in. If I start at X and run halfway around, how many degrees did I turn if I'm standing at the center? 180. Let's write that on the inside. Okay, go another 90. Where do I end up? 270. And then one complete lap is 360. Does that make sense?
Yes.
Okay, now, we are also going to liken the degrees when we look at radians, pi divided by 4. What did I tell you pi divided by 4 was before? How many degrees is this? 45 degrees. So this is going to be 45. What do I have at the top? 90. Mental math, what do I have next? Then? What's next? 180. Then? 225, mental math. Next up, 3 pi over 2. 270. And 7 pi over 4. Ah, just like the warm-up. One full revolution is 360. Does that make sense?
Yep.
Yes. Okay, now I'm going to blow your mind. Are you ready? Do you remember this special one, 3 pi over 2 I told you about? I said you may eventually look at it like this. How many degrees is pi over 2? Pi over 2 is how many degrees? What's 3 90s?
270.
Yeah? Mind blown? So if I say 3 pi over 4s, I want 3 45s. Right? Some of you will see the circle this way. That's why I wanted to show it to you, because then it makes a little bit easier mental math. Some of you would rather multiply 3 times 90 than add 90 to 180. Yes? It's up to you. Questions? Okay, what's the next one on your list?
Pi over 3.
Pi over 3? All right, so let's look at pi over 3. I'm going to erase my pizza analogy. I talked about that. All right, so we're starting here at x, and we're going to look at pi over 3. How many parts do I divide pi over 3 up into?
Semicircle.
For the semicircle, good question.
3.
3. So here's pi, all the way over here. I want to take pi and divide it into 3 parts. So that gives me these here, right? Like a little Martian. Pi over 3s. All right, so if I travel to here, this is pi over 3. Now that we've talked about this, do you know what the degrees are? pi divided by 3. How many degrees is pi over 3? Nope. Pi divided by 3. 60. How many degrees is pi? 180. What's 180 divided by 3? 60. All right, so if this is 1 pi over 3, what's the next one? 2 pi over 3. How many degrees is that? 120. And then what? Then I have 3 pi over 3, right, Mike? 3 pi over 3, which reduces to pi. Then if I have my little things down here, what's next? How many degrees? 240. And then what? 5 pi over 3, which you said is 300. And then I get back at the beginning, which is 2 pi, or 360 degrees. Yes? Yes.
Are we going to have to divide it where it's not even like that?
The only unit circle values have a denominator of 2, 3, 6, which is what we're going to do next, and 4. So they're all very easy numbers to work with. Okay? Questions on that? All right, let's do the last one, which is what?
Pi over 6.
Okay, now, in your head, pi over 6. Take 180, which is pi, divide by 6. How many degrees is that? 30. All right? This is one of those first times, you're going to see this a lot in the unit. Denominator of 3 is 60 degrees. Denominator of 6 is 30 degrees. And that should make sense. You're dividing it up into more parts, so the degrees should be smaller. So here's your pi, which we said is 180. Here's your 2 pi, which we said is 360. I'm going to divide this up into 6 parts. I cut it in half, and then I made thirds. I cut it in half and made thirds. My first value is pi over 6, which you told me was 30 degrees. What's next? 2 pi over 6, what does it reduce to? Pi over 3, which is how many degrees? 60 degrees. Then what's next? 1 pi over 6, 2 pi over 6. What does 3 pi over 6 reduce to? Pi over 2. How many degrees? 90. 1, 2, 3, 4 pi over 6 reduces to 2 pi over 3, which is 120. 2 pi over 3s, right? 2 pi over 3s, we said was 60 degrees. Then what? 5 pi over 6, which is 150. Okay, now, I'm going to do the bottom half. But I want you to ask any questions of why, can you explain, this doesn't make sense, any of that. Does it activate in your brain how they fit together? Do you understand the reducing? Do you understand the degrees? All right, let's do the bottom half. How many? 7 pi over 6? Right, notice we switched to the improper fractions because we're beyond pi. How many degrees is that? 7 30s. 210. Then what's next? 8 pi over 6, which is 240. And that reduces to 4 pi over 3. 240. And then our good old friend what? 270, which is 3 pi over 2. 270. And then, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 pi over 6 reduces to 5 pi over 3, which is 300. And then 11 pi over 6, which is 330. All right, now, what you're going to do, if you haven't done this already, is you're going to look at the degrees, and you're going to look at your radians, and I need you to put all 4 of these diagrams into one on the right-hand side.